asking us to use the first derivative test and concavity/inflection points to sketch the graphs of fx, f prime x, and f double x for the function of 1 over 4 times x to the fourth minus x cubed plus 7. So to find the first prime of the function, you do the derivative of each term. So for the first term, you use the power rule. For the second term, you use the power rule as well. And then for the third term, there's no derivative because it is an identity rule. So from here, you can simplify this term by crossing out the 4's. So you will get x cubed minus 3x squared. And then from there, you equal them to 0 to find your critical points. And from here, you can tell that you can factor out an x squared times x minus 3. And then from here, you equal both of them to 0. So then you square root to this side, square root to this side, so you will leave with x equals 0. And this side, you bring the 3 to this side, so then it would be x equals 3. So these will be your critical points. So now that after we found our CPs, we put them in an f prime x chart. And in this side, we put negative infinity, and on this side, we put infinity. And on these two lines, we are going to put our critical points, which were 0 and 3. And in each interval, we can find any number that fits each one, within each one. So for -8 and 0, we can find -1. 0 to 3, we can choose 2. And 3 to 8, to positive infinity, we can do 4. All right. So now that we found the numbers that we are going to plug in, we plug them in into the f prime function, which can be this one. So then when we plug in -1, it would be -1 squared times -1 minus 3. -1 squared becomes a positive, and -1 minus 3 is a negative. So a positive times a negative is a negative. Then when we plug in 2, we get 2 squared times 2 minus 3. 2 squared is positive, and 2 minus 3 is a negative. So positive times a negative is a negative. And then when we plug in the 4, we get 4 squared times 4 minus 3. 4 squared is a positive. 4 minus 3 is a positive. So positive times a positive is a positive. So after we find the signs, we plug them into the corresponding intervals for f prime. And now we do negative, negative, positive. And these signs will now help us determine in which point is fx increasing or decreasing. So at this interval, fx is decreasing. On this one, it's decreasing. And on 3 to positive infinity, it's increasing. So from the chart, we can see that at x equals 3, there is a local minimum. As you can see right here, it is a local minimum. And then at x equals 0, it is just a critical point.
Okay, so now in step 2 of this video, we're gonna find the concavity/inflection point of this equation. So we're gonna start off with the f prime x, which was found as x cubed minus 3x squared. So in order to find the answer of the inflection point / concavity, we need to find the derivative. So it would be the second derivative of this equation. So it would be 3x squared minus 6x. And so now we can equal this to 0 to find the inflection points. And then we can see that we can factor out at 3x. So we factor out at 3x times x minus 2. So now we equal each one to 0. So it would be 3x equaling to 0. X minus 2 equal to 0. We divide this by 3. which would be x equals to 0. And then this one, you move the 2 to the other side, and it would be x equals to 2. So now these are your possible inflection points. These, you're going to put these in a graph of f double prime x and fx, comparing them. And then you have because you have 2 inflection points, you're going to have 2 lines. And for this one, it would be 0 and 2. From negative infinity to positive infinity. So between negative infinity and 0, we can choose a point which would be negative 1. Between 0 and 2, we can choose a point at 1. And between 2 and positive infinity, we can choose 3. Now these points, we have to put them back into the equation of f double prime x. So I'm choosing this one because it's the simplest one of all. And I am going to put at f double prime at negative 1. And I'm going to plug it into the equation would be 3 times negative 1 times negative 1 minus 2. So 3 times negative 1 is negative. Negative 1 minus 2 is a negative. Negative times a negative is a positive. And then again, I will do that for the point at 1. Plugged it in. 3 times 1 times 1 minus 2. And 3 times 1 is a positive. 1 minus 2 is a negative. Positive times a negative is a negative. And then again for the point at 3. So it would be 3 times 3 times 3 minus 2. 3 times 3 is a positive. 3 minus 2 is a positive. So positive times a positive is a positive. Now you're going to put these signs into the graph. So it would be a positive, a negative, and a positive. Now the difference between this table and the other one was that in this one we're going to find the concavity. So if it's a positive, it would be concave up. If it's a negative, it will be concave down. And this will be concave up. So now we can tell that at 0, there is an inflection point, and also at 2 because they have their signs that are changing from here to here, and then from here to here. And it would be at x equals 2. And these are your inflection points.
To graph the function of fx, we're going to look at these 2 charts. In this chart, we can see that there's 2 inflection points, x equals 0 and x equals 2. So from 0, there's going to be an inflection point here at 7 because it is a y-intercept from the original function, and the other inflection point is going to be at 2.
fx, we're going to come from the top and we're going to decrease down. We're going to touch up the inflection point at 7 because there is a critical point at 0. And we're going to decrease a little bit more down, and it's going to touch at the inflection point at 2. Then we're going to decrease a little bit more down, and we're going to increase back because there's a local minimum at 3. Okay, so in order to graph f prime x, we're going to use the first table, and in the first table it says coming from the negative side. So we're going to start at the negative side of the table, which is here, and we're going to touch at 0, come right back down because it's still negative, and then come right back up, touch at 3, and become positive because it changes from negative to positive. And then for f double prime x, we're going to use the second table, and it says it's coming from the positive side, touches at 0, comes down at negative, has to touch at 2, and becomes positive again. And this is the end of this video.